Hello friends, welcome back. Hearty welcome to you. Let's solve some word problems using quadratic formula which we have learned in last session. So here is one of the word problem. Three consecutive positive integers are such that the sum of the square of the first and the product of the other two is 232. Find the integers. So let's try to understand this. Three consecutive positive integers, that tells me I'll just go for x plus 1 and x plus 2. These are three consecutive positive integers such that sum of the square of the first, that means I have to square the first one, x square, sum, so I have to add it to what? The product of the other two, that means x plus 1 into x plus 2 is given as equal to 232. So you can see this scenario comes down to a quadratic equation and we have to solve it using quadratic formula or factorization. We'll do it with quadratic formula just as a practice. So let me repeat this again. Three consecutive positive integers are such that x plus 1, x plus 2, sum of the square of the first, that means x square, and the product of the other two, that is x plus 1 into x plus 2, the product and the square, you sum it up, is equal to 232. Now we have to just simplify this and we have to apply the quadratic formula. So simple it is. Now x square is x square only. What is x plus 1 into x plus 2? We will have x square plus 3x plus 2 equal to 232. Now let's simplify this. We will have 2x square plus 3x minus 230 is equal to 0. Now this is the quadratic equation we have. Let's find out what are the values of a, b, c. A equal to 2, b equal to 3, c equal to minus 230. Now let's put it in the formula. X equal to minus b, that is minus 3, plus r minus b square is 3 square minus 4ac, that is 4 into 2 into c is minus 230 divided by 2a, that's equal to 2 into 2. So next step will be x equal to minus 3 plus or minus b square is 9, minus of minus is plus, 4 into 2 8, 8 into 230 is 1840. You can just check that, divided by 4, which is nothing but equal to minus 3 plus or minus square root of 1849 divided by 4, which is equal to minus 3 plus or minus square root of 1849, 4 square, 5 square, so it should be 4 and this should be 3 or 7. Seems to be 3 is a better solution. So plus or minus 43 divided by 4. This is finding out the square root by estimation method. Now we have the first two digits. This is one group, this is one group. What we learned in 8th class. 4 square is 16, 5 square is 25. So first digit is 4, ending with 9, so should be 3 or 7, but near to 1600, so it is 43. So we have two values now. The first value is minus 3 plus 43 divided by 4. The other one is obviously ruled out because it's a negative value. So what we have here, 43 minus 3 is 40. 40 divided by 4 is 10. So x is 10, x plus 1 is 11, x plus 2 is 12. Now let's check the condition. Always don't check the equation, check the condition, because you can write the equation wrong but the condition should be satisfied. Square of the first, that is 100, plus product of the other two, 11 into 12, should be equal to 232. Seems to be okay to me. 11 12s are 132. 132 plus 100 is 232. Let's solve one more problem. the difference of squares of two numbers is 120. The difference of squares of two numbers is 120. Let us say there are two numbers, one large number and the other one is small number. Okay. If the larger number is 9 less than twice that smaller number, this is important. If the larger number is equal to 9 less than twice that smaller number, find the two numbers. Let's start with small number equal to x. Then what will be the large number? Large number is 9 less than twice the smaller number. That means 2x minus 9. Is this okay? If the larger number is 9 less than twice the smaller number, find the two numbers. What is the first condition we have? The difference of the squares of two numbers is 120. We know that the difference of squares of the two numbers is 120. So we will take large number first, square it up, because we said difference of squares. So 2x minus 9 whole square minus smaller number square, that is x square, is given as equal to 120. Now simplify this. A minus b whole square formula. A square 4x square plus b square 81 minus 2ab, that is 2 into 9 minus 36x minus x square minus 120 equal to 0. Or can I say 3x square minus 36x minus 39 equal to 0, or x square minus 12x minus 13 equal to 0. Now this seems to be easy. We can do it by factorization also, but just for the sake of it, we'll do with quadratic formula so that we practice it. Now if we compare the value of a, b, c, we have a equal to 1, b equal to minus 12, c equal to minus 13. X is equal to minus b, that is minus of minus 12, 12, plus or minus b square, that is 144, minus 4 into 1 into minus 13. Minus 4ac divided by 2a. Let us simplify this. 12 plus or minus square root of 144, then minus into minus is plus, 4 into 13 is 52 divided by 2. That's nothing but 12 plus or minus 144 plus 52 is 196. Square root of that is 14 divided by 2. So 12 plus 14 by 2 is nothing but 13. So the smaller number x is equal to 13. If x equal to 13, what will be the other number? Other number will be, larger number will be 2 times 13 and subtract 9. That's nothing but equal to 17. So we can check that 17 square minus 13 square should be equal to 120. So that's another example word problem on quadratic equations. We have solved it with quadratic formula. You can actually do it with factorization also. This is pretty simple. X minus 13 into x plus 1. X square minus 13x minus 12x minus 13. So x equal to 13 or minus 1. So the number is 13. So I'll catch you again in the next session. We'll do in the next session some more word problems. After that we will look into the last topic of quadratic equation, that is nature of roots of the quadratic equation. So when we say quadratic formula, we have minus b plus or minus square root of b square minus 4ac by 2a. b square minus 4ac is called as discriminant because it decides what will be the nature of the quadratic equation roots. If that is greater than 0, the roots will be real and distinct. If that is equal to 0, the roots will be real and equal. If that is less than 0, the roots are imaginary, so we cannot find out any real solutions. That we will learn in the next session. Till then, thanks for your support. Bye for now.